Namaskar. In this module, we are going to learn about unit vectors and rectangular components of a vectors. What we will learn after completion of this module: be capable to define unit vector, able to find unit vector along the direction of a given vector, we can capable to resolve vector in the given direction. In a plane, consider Cartesian plane, x, y, z axis representing Cartesian coordinates, then I cap, j cap and k cap are unit vectors along x-axis, y-axis and z-axis. Before knowing about a vector, we must recap what is a scalar. A scalar, a quantity which having magnitude only, no direction associated with a scalar. For example, speed, work. But what is vector? Vector is a quantity having both magnitude and direction. For example, displacement, velocity, acceleration, force, momentum, torque, etc. A vector is represented by a bold letter like A or A overhead an arrow and read as vector A. For example, in the given graph, a line originates from origin and pointed towards B. So here we can say OB is a vector. Now what is unit vector? Unit vector has magnitude equal to 1. It shows direction only. It has no dimension and unit. It is used to specify only the direction along the given vector. Unit vectors along x, y and z axis of a rectangular coordinate system are denoted by I cap, j cap and k cap respectively, as shown in this given figure. Since these are the unit vectors, so mod of I cap is equal to mod of j cap equal to mod of k cap, and these are equal to 1. How we find unit vector along the direction of a given vector? Simple formula is unit vector is equal to vector divided by magnitude of that vector. Here A cap means unit vector along the direction of vector A. It is equal to vector A divided by mod of vector A. Now the rectangular components of a vector. Splitting of a vector along axis is known as components of a vector. In the given graph, OB is represented by vector A, making angle theta with x-axis. We can resolve this vector A along x-axis and y-axis. Later along, so the projection of OB along x-axis is OP, that we are here representing as AX. So this OP is equal to A cos theta. Similarly, y component of vector A is AY, and that is equal to A sin theta. So vector A is equal to AX I cap plus AY j cap. Components of a vector is the effect of a vector along axis. Now, the applications unit vectors are applied in many ways. Few of them are here. Unit vector is used in physics problems for simplification. It is helpful in resolving forces. It is useful in motion analysis, that is helpful to deal motion in 2 dimension or 3 dimension, that we will learn in the chapter motion in plane. It is also helpful in engineering. Now, a simple problem to just recap what we have learned. Question is, the position vector of a particle is given by r vector equal to 3 I cap minus 2 j cap meter. What is the unit vector along r vector, and what is the angle between r vector and x axis? Now let us see the solution. First, given r vector equal to 3 I cap minus 2 j cap meter, in figure we can see, that is in the graph, since x coordinate is 3, so positive side, and y coordinate is minus 2, so negative side. So this vector is r vector. Now formula we just learned, r cap, that is unit vector r, is equal to r vector by modulus of r vector. Now modulus of r vector is equal to a square of x component plus a square of y component, that we can say root under a square plus b square. Here x component is 3 and y component is minus 2, so 3 square plus minus 2 square, that is 9 plus 4, that is root 13. So r cap equal to r vector by modulus of r vector, that we can write as 3 I cap minus 2 j cap by root 13. Splitting it, 3 by root 13 I cap minus 2 by root 13 j cap. Here x component of unit vector is rx, that is r cos theta, and here r cos theta is 3 by root 13, and y component, that is ry, equal to r sin theta, and this is equal to minus 2 by 13. So tan theta equal to, means angle between r and x axis, ry by rx, that is r sin theta by r cos theta, r will cancel, so here minus 2 by 13. Hope this content will help us to understand unit vectors. Thank you.